Around the world, the use of renewable energy is on the rise. According to SEDA Mestec, most common renewable energy are wind turbine, solar, hydroelectric energy, biomass, and etc. The speed of development is not tally with the developments of renewable energy. In Malaysia, the awareness and the use of renewable energy is still a big challenge. Rapid growth in economic and living standards have led to massive consumptions of fossil fuel in order to render for the huge energy demand. Fossil fuels such as coal, oil, and natural gases is depleting days by days. This has caused problems like shortage of fossil fuels, climate changes, and environmental pollutions. Comparing to other sectors, concrete industries and buildings are the largest energy consumers worldwide, accounting for about 40% of energy consumptions as reported by the United Nations Environmental Programs. Thus, sustainable and environmentally friendly solutions for alternative renewable energy sources must be developed so to resolve current energy situations and prepare us for the future. Lignocellulosic biomass is a natural alternative renewable resource that can be obtained in large quantities around the world. All the biomass is able to store solar energy in their cells through photosynthesis and convert it into chemical energy as a main energy resources in the form of carbohydrates to survive. These types of chemical energy is able to be used as a power to generate electricity when the biomass undergoes a high temperature of combustion. Government of Malaysia recognized biomass as a high potential renewable energy source, and there are numerous biomass power stations in Malaysia. Commercially, it needs high temperature combustions and gasifications together with a steam or gas turbine to generate electricity, which in return use another environmental pollution. Hence, there is a need to discover alternative renewable energy that brings positive benefits to the environment in line with the National Renewable Energy Policy, which is achieving 20% renewable energy capacity mix by 2025. On the other hand, scientists and engineers are searching innovative substances with cementitious properties that are able to replace cement and at the same time fulfills the green building requirements. Their research proves that concrete using lignocellulosic biomass result in high compression strength and able to reduce the emissions of CO2 during productions. Furthermore, the durability, chemical resistance property, low heat developments, and other mechanical properties of such concrete is higher than the concrete that using just ordinary Portland cement. With the outbreak of the research, part of the cement content able to replace with recyclable material and resulting satisfactory performance of concrete. However, the potentials of biomass as renewable resource in concrete is yet fully discovered. Biomass eventually has been greatly proven by researchers on its capability in enhancing concrete properties. At the same time, it's also believed can be catalyzed to generate electricity under certain exposing criteria.
With the outbreak of the present research, we decided to replace part of the cement content with biomass as renewable resource, which result in satisfactory performance of concrete. Hence, by replacing biomass as part of the binding material in concrete, it enables the usage of sustainable materials without chemical pollution to the environment.
Incorporations of catalyzed biomass and concrete constituents can re-character public impressions to concrete where it is no longer only gives strength and integrity to the building but generating electricity under thermal exposure. Research has been carried out at INTI International University, Malaysia, to investigate the feasibility of incorporating variety of lignocellulosic biomasses and active catalysts in concrete to generate electricity and at the same time retain the good properties of concrete. The result shows that such concrete mix combinations are feasible to generate electricity with a firm external circuit, result with an average voltage density of 120 volt per meter square and less than 10% of strength degradations. It is named as Catalyzed Biomass Concrete, and it has been patented under patent ID of PI2018003068 and PI2021002342. Catalyzed biomass concrete during fresh stages undergoes hydrations and pozzolanic reactions for strength development, and at the same time catalyzation reactions with active catalysts to oxidize biomasses and activate the electric potential in the concrete. Catalyzed biomass concrete is an innovative concrete that can dismiss the carbon dioxide emissions in the process of preparations and able to generate voltage under normal servicing conditions. Catalyzed biomass concrete ready to deliver electricity in desire and can be used as non-bearing wall, cement plastering work and concrete structure with confirmations of its quality, yet the capacity to produce electricity and direct power for the gadget in our daily life. Catalyzed biomass concrete able to provide strength and durability as conventional concrete and at the same time also able to oxidize biomass and generate the voltage which may be used for electrical appliances provided a proper magnification circuit is established.
The main purpose of doing compression tests is to make sure our invention can be used for both structural and non-structural applications.
Catalyzed biomass concrete able to produce voltages under temperature difference, and it can be worked day and night instead of installing solar panel which only works during sunny day. With catalyzed biomass concrete, the voltage generation is promising and sustainable. Catalyzed biomass concrete is definitely a breakthrough in advanced concrete materials.
With catalyzed biomass concrete, it reduces the dependency on fossil fuel and at the same time produce new heat and solar energy harvesting method in concrete research. It is also an alternative product to solar panel that harvesting heat and solar to generate electricity.
Catalyzed biomass concrete able to produce voltage with under different temperature changes, and it can work day and night. Imagine today we are having a solar panel on our house rooftop. Instead of installing solar panel which only works during sunny days, with our CBC it's able to generate voltage, okay, and the voltage generation is promising and sustainable. So CBC is definitely a breakthrough in advanced concrete materials. Catalyzed biomass concrete has great significant contributions on at least 4 different areas. It is a new and potential renewable energy in line with renewable energy policy in 2018 (SEDA). It unlocks electric potential of POFA or biomass in concrete. It incorporates renewable energy harvester in buildings in line with industrialized building systems, and it is a pioneer study for researchers in advanced concrete materials. These are some achievements and publications for catalyzed biomass concrete. It is still a new topic, and the potential of catalyzed biomass concrete in construction market is extremely high. Especially it is in line with our government policy in sustainable constructions and renewable energy policy.